Okay, in this video we're going to use variation of parameters to solve a differential equation, and we're going to kind of do it the long way. So when you look at this or you look it up, you're going to find a lot of formulas that you can just use. It's not really clear where they come from, but in doing the problem that we're going to do, you'll see where those formulas come from, and hopefully this will be helpful to you. So I like to do it the long way, to be honest, because I can remember how to do that, and I can't always remember all the formulas that I need to use. So let's take a look at the procedure and then we'll do the problem. So here's what it looks like. First thing you do is you're going to find y sub c, which is take the differential equation and make it homogeneous, so set equal to 0 instead, and then figure out the solution to that. Then you look at the solution that you got there, and you basically just say the particular solution, y sub p, probably looks a lot like the solution that we just got. So your y sub p is going to end up looking like u1 y1 plus u2 y2, where u1 and u2 are actually just functions of x. So that's maybe the weirdest part of this. Once we do that, we're going to then find yp prime. So we're going to find the derivative of that thing. And then we're going to use that and just, we're going to make the assumption that u1 prime y1 plus u2 prime y2, that's really hard to read, is equal to 0. So it's a big assumption that we make. But we're going to do that. And that's going to give us one equation that we can work with. Then we're going to rewrite y prime and use that to find y double prime, and you'll see what happens there. We're going to take those and we're going to substitute into the differential equation, and then we're going to ultimately solve that and end up with this other equation. So it's a times, I don't know, in my head I would just say prime prime plus prime prime equals g of x. So looking at that, we actually get two equations. We make a system out of those, and then we solve the system. After we solve the system, we'll know what u1 prime is and u2 prime is. We'll know what those are. And then we're going to do some integration to figure out what u1 and u2 are. And once we know that, we will write our answer as y sub p plus y sub c. So it's a lot of steps, and we're going to do it. So here's our example. So we want to solve y double prime plus 3y prime plus 2y is equal to sine of e to the x. So sine of e to the x is kind of like a weird function to have for g of x. So we're going to use variation of parameters, see what we can get. So first we want to solve the homogeneous equation. So we end up with a complementary equation. And that's where we just turn g of x into 0. And so this you probably solved a lot at this point. There's a characteristic equation. And we're going to end up factoring the characteristic equation and finding the roots of that. Two real distinct roots. So we actually know what y sub c is at this point. So y sub c is c1 e to the negative 2x plus c2 e to the negative x. Okay, so that's what y sub c is. We use y sub c to figure out what we think y sub p is. So basically what you do is you're just going to turn this c1 into u1. And then we're going to turn this c2 into u2. So it's a strange process, but that's what you do every time. So there's actually three things here that we're going to want to carry forward with us. We have our particular solution, or what we think it looks like. We have the complementary solution, which is going to be a part of our overall solution. And then also we have the differential equation. So I'm going to bring forward two of the things that we need and keep going. So we have our differential equation, and then we just figured out that y sub p should probably look like u1 e to the negative 2x plus u2 e to the negative x. From here, we're going to find the derivative, right? So we're going to find y prime, y sub p prime. And that's going to be, so we're using the product rule because u1 is actually a function of x and u2 is also a function of x. So product rule here. So it's going to be the derivative of e to the negative 2x is negative 2 e to the negative 2x. So I just wrote it that way. So it's first derivative of the second plus second derivative of the first. The derivative of u1 is just u1 prime. And then we do this for the second term also. So first derivative of the second plus second derivative of the first. Okay, so we have this. And what I'm going to do is I'm going to rearrange it so that the things that don't have primes, like u1 prime, u2 prime, I'm going to move those to the back. So I'm just kind of rearranging here. So nothing too exciting. So we rewrite it. I move all the primes to the back because we're going to do something with those. So here's what we do with those. We're going to assume that this term is just equal to 0. We don't know what u1 is. We don't know what u2 is. So we can make this kind of assumption. So that's an assumption we're going to make. So that gives us our first equation that we're going to solve. Well, the first equation in the system of equations that we're going to solve. So it's u1 prime. So if you really look at that, it's actually like u1 prime times y1 plus u2 prime times y2 is equal to 0. But for our case, it's u1 prime e to the negative 2x plus u2 prime e to the negative x equals 0. Based on that assumption, we also can rewrite what y prime looks like, right? Because we just said those last two terms are 0. So y prime is actually just this thing. All right, so I'm going to carry that forward. I'm going to carry the differential equation, the particular solution, and this first equation. So you're going to see what I bring forward. So new page. These are things we have. We also figured out this equation because we're looking to build a system of equations here. So this is the first of the two equations that we need. All right. Now, if you look at the differential equation, we could substitute for y at this point. We could substitute for y prime. We need to find y double prime. So we're going to find y double prime. So here, product rule again, first derivative of the second plus second derivative of the first. The derivative of the first in this case is negative 2 u prime, u1 prime, I should say. And then another product rule. So it's first derivative of the second plus second derivative of the first. So we have this. That actually doesn't get any better. But now we can make some substitutions, right? So this is y double prime, so we're going to substitute it there. This is y prime, so we're going to substitute it here. And then this is just y, so we can substitute it there. All right, so 3 substitutions we can make. So let's see. So this is our differential equation. And now I'm going to actually make the substitution. So this is just a ton of writing. So we substitute in y double prime. And then plus 3, substitute in y prime. There's nothing really exciting about this. And then plus 2, substitute in y. And then all of this should be equal to just sine of x, sine of e to the x, I should say. Okay, and now if you look through this thing, there's actually a ton of stuff that cancels, right? Look at the u1 e to the negative 2x terms. There's 4 of them, then there's negative 6 of them, and then there's 2 of them. So actually, all of these terms are going to cancel when we distribute and collect like terms. Now look at basically we're looking at things that don't have the prime with them. So if you look at all the u2 e to the negative x terms, we have 1 of them, then negative 3 of them, and then 2 of them. So it turns out all of those are also going to cancel. And then we're just left with our second equation. So our second equation is negative 2 u1 prime e to the negative 2x minus u2 prime e to the negative x is equal to sine of e to the x. All right, so now we have 2 equations, 2 unknowns. Let's copy some stuff forward. 2 equations, 2 unknowns. This is our system of equations. And what are we doing? We're trying to solve this differential equation. You always want to keep track of this. We're trying to solve this differential equation. And we know that basically the particular solution should look like u1 e to the negative 2x plus u2 e to the negative x. We know that because we found y sub c was c1 e to the negative 2x plus c2 e to the negative x. All those are good things to keep in mind. Let's look at the system of equations. So, I don't know, look at the u2 prime e to the negative x terms. They're equal but opposite in the 2 equations, so I can actually just add these 2 equations. So I'm going to do that. It gives me negative u1 prime e to the negative 2x equals sine of e to the x. That's pretty good. That means that solving here, u1 prime, so I divided by e to the negative 2x, but then I moved it to the numerator as e to the positive 2x. So u1 prime is negative e to the 2x sine of e to the x. So far, so good. There's actually something weird we can do here. It's not really super weird, but this is u1 prime. And if you look up at the 2 equations that we have, this is also u1 prime. So what I'm going to do is I'm going to make the substitution right now. And it's actually easier to find u2, so I'm just going to go ahead and do that. So making a substitution here into that first equation, I'm replacing u1 prime. And I end up with this. And then if we clean up, so e to the 2x times e to the negative 2x is e to the 0, which is 1. So really we just have negative sine of e to the x plus u2 prime e to the negative x equals 0. If you add sine e to the x to both sides and then divide by e to the negative x, we actually end up with u2 prime is e to the x sine of e to the x. And this means that u2 is the integral of that thing. You kind of don't worry about the plus c's when you do this all that much because they're just like generic constants. And so this this is straight U substitution if you want to do it. Let u equal, well, it's confusing because there's a lot of u's involved here, but if we let u equal e to the x, then that's just sine of u du. And so when we integrate that, we get negative cosine of u. So we now know that u sub 2 is negative cosine of e to the x. That's useful. All right, so what I'm going to do, I'm going to bring forward u1 prime and a bunch of other stuff. So u1 prime is negative e to the 2x sine of e to the x. All this other stuff I know is on the right corner there, and we're going to solve. So I'm actually going to multiply through by a negative first here, mostly because I know myself when I'm solving these, I tend to forget that negative in the long run. So I just move it over to the other side and don't really worry about it. So I moved it over, and then I'm saying that negative u1 is the integral of what's on the right-hand side. The right-hand side actually is going to be integration by parts. So first, look at e to the 2x. And notice that e to the 2x is e to the x times e to the x. So I can rewrite that integrand. I kind of like to show more work than I think a lot of people like to show. But it's just easier when you go back to check your work to find where you went wrong if you just show all this stuff. So now I need to do integration by parts. So I'm going to let u equal e to the x. I'm going to let dv equal e to the x sine of e to the x, which, if you remember, we actually just did to find u2, u sub 2. So du is just e to the x, dx, I guess, but I always forget to write that. And then v is negative cosine of e to the x. So it's going to be negative u1 is uv, and then it's minus the integral of v du, but minus negative is plus. Now we get this. E to the x cosine of e to the x is kind of a very straightforward integral. Let u equal e to the x. It's just the integral of cosine of u du. So let's do that. We're kind of almost done with this problem, I guess. So we're integrating, as I said, cosine of u du, so we just get back to sine of u, which is e to the x. And so now we know what u1 is. Excuse me. So we know what u1 is. We know what u2 is. We know that y sub p is u1 e to the negative 2x plus u2 e to the negative x. And we're trying to solve that differential equation. So let's go one more page and then we'll be done. So here's all the things we know. So that means that y sub p should be, so we're making our replacements, right? u1 and then e to the negative 2x, and then plus u2 e to the negative 2x, e to the negative x. Let's kind of simplify this. So I'm going to distribute the e to the negative 2x to get e to the negative x cosine of x, because e to the x times e to the negative 2x is e to the x minus 2x, or e to the negative x. So we have this. If you look at that, we have e to the negative x cosine of e to the x, and then minus cosine of e to the x, e to the x, e to the negative x. They're the same. So these actually cancel. So y sub p is pretty simple in the end, and we get that. And then we know, because of what we're trying to solve this, we know the solution should be y sub p plus y sub c. We found y sub p, we found y sub c. We're done. These take a while if you do them kind of the long, I mean, I said it was going to be the long way. So they do take a while, but we got it. So that's it. All right. So maybe rewind, take a look at some of the steps, try to work it out on your own. I hope you found this helpful, and good luck.